Okay, Assalamualaikum students. Students, in this lecture, we are going to do common ion effect, right? What is common ion effect? Common ion effect is the topic that is needed almost in every equilibrium concept. Like if you want to study all these in detail, you must know that what is common ion effect. And secondly, you must know that as long as the temperature is the same, the equilibrium constants are same. Right? The equilibrium constants are not affected by concentration. They're affected only by temperature. So we will relate all these things in the next lectures. But right now, what is common ion effect? The common ion effect is the solubility or the ionization of a weak electrolyte. Look, the solubility or the ionization of weak electrolyte is suppressed by strong electrolyte if both electrolyte have a common ion. What is the meaning of this? See, this is a container. In this container, there is this weak electrolyte. For example, ethanoic acid, which is a weak acid. It will ionize partially. Ionize partially. It was ionizing up to some extent. It has its own Ka value. You know this. Would its Ka value change? No. As long as the temperature remains the same. Right? It was ionized. Now, what happened? You added HCl. When you are adding HCl, it produces a lot of H+. It produces a lot of H+. So in this container, there was some H+ from this. When you added HCl, there is too much H+ in that container. When there's too much H+, the H+ is much more. They are colliding, but it's not going in the backward direction because it's already fully ionized. But when the H+ is more, they can collide. When they can collide, due to collision, the rate of the backward will increase. The equilibrium shift to left-hand side, and this is less ionized. It is less ionized, right? The ionization is suppressed because it's providing too much H+. The H+ is much more in that container. Their collision with this is much more. It will go in the backward direction. So what I've written? The solubility of the weak electrolyte is suppressed by strong electrolyte. If both have a common ion, the strong electrolyte increase the concentration of the common ion and it shifts the equilibrium for the weak to the left-hand side. As a result, the solubility of the weak electrolyte lowers. So ethanoic acid is less ionized in HCl. If I take another example. What I'm doing. Not bad. I converted this, but okay. Sorry. Now suppose I have containers. In that container, there is what? AgCl, which is very, very slightly soluble. Right? It was very slightly soluble. You know what I did? I added NaCl. What will happen? It's a strong electrolyte. You know, all group 1 electrolytes are strong electrolyte. So if it is strong, it will fully dissolve. As a result, the concentration of the chloride is much more. If the concentration of the chloride is more, the collision of the chloride with Ag plus would be more, and when the collisions are more, the rate of the backward is more, and you shift the equilibrium to the left-hand side. So AgCl is less dissolved in NaCl. I can use the same explanation this way. Look, if I add, suppose, AgNO3, all nitrates are strong electrolyte, dissolve completely. Huh? If I am adding NaCl, it increases the Cl and shift the equilibrium to the left. If I am adding AgNO3, it will increase what? The Ag plus. Don't you think their collision will increase and shift the equilibrium to the left-hand side? So the solubility of the weak is suppressed by strong if there is a common ion. So if I ask you that will calcium hydroxide more soluble or less soluble in NaOH? Which is a strong electrolyte? See, the OH negative concentration is increased because of the NaOH. The collision would be more, the equilibrium shift to the left-hand side. Now there is a misconception. Look, this is NaOH. Full dissolve. There is this calcium hydroxide. But that is partially dissolved, sorry. This is water. H plus and OH. It is fully dissolved. Suppose its K value, the ionization constant, is 1 into 10 power minus. Suppose, like these are, I'm assuming, right? Like 0.6, minus 6. And its Kw is 1 into 10 power minus 14. Which one is very low? This one. So it is very weak. It is weak. It is strong. Now, NaOH will suppress this as well as this. But if these are present in water, so what do you think? This is relatively stronger than this. So actually calcium hydroxide will suppress water. Water cannot suppress hydroxide. Like every strong suppress the relatively weak. So we can say that NaOH will increase OH. It will suppress this. But if I take calcium hydroxide, it will suppress what? Water only. So in the presence of NaOH, both will be suppressed from ionization. In calcium hydroxide, it cannot suppress NaOH, but it can suppress water. Right? So they suppress the ionization, but they can't change the value of these constant. They will change when the temperature will change. You know, like suppose KW, suppose how much 8, and it is what 2 into, is there anything that's making it? No, I'm going to take it 16. Suppose it is 16. Now the 16 is equal to, suppose 4 into 4. But if I make it 8, it becomes 2. It's still 16. So unnecessarily, the temperature is not changed. The KW remains the same. The KW is actually this much. I'm assuming this as 16 so that you can understand. It's not this. Right? So the value remains the same. This is not going to change. This is not going to change. The values can change, but the product or the ratios remain same. These are equilibrium constants. So if you put calcium hydroxide in water, there will be more OH, but the H plus decrease. If you put NaOH in water, there will be more OH. Huh? But the calcium remains, the calcium will decrease for this constant. Do you understand what I'm saying? So for this time, I think this is sufficient. That what is common ion effect? That every strong electrolyte suppress the solubility or the ionization of weak electrolyte, because a strong increase the concentration of the common ion and it shift the equilibrium for the weak electrolyte to the left hand side. See you in the next lecture for the buffers. Don't forget to like, share, and subscribe my channel, right? Allah Hafiz.